68. We're asked to find the zeros. Y equals x squared minus 4. A 0 is basically an x-intercept. Technically, it is an x value such that the y is 0. So we're looking for some x that makes y 0. So what we can do is substitute 0 in place of y. So 0 is equal to x squared minus 4. And right in the vein with the ones we've done previously, we could factor this left side as a difference of two squares. This becomes x plus 2, x minus 2. And now we can set both of these individually equal to 0, setting this one and this one equal to 0. X plus 2 is 0, or x minus 2 is 0. Solving for x, we get x is both positive and negative 2. Those are your zeros, negative 2 and positive 2. Number 71. I'm going to skip 71 for a second, move on to looking at a couple of the ones on the back page just in terms of time. Okay, I couldn't see the instructions on that. 72. It says we need to find the axis of symmetry in vertex. A is the nobody does. 72, y is equal to negative 10 x squared minus 40x minus 9. We need A, the axis of symmetry, and B, the vertex. If we have a parabola, this imaginary line that passes through the middle of it is called the axis of symmetry. That is the axis of symmetry. This point here that the axis of symmetry passes through, that's the vertex. To find the axis of symmetry, the axis of symmetry is given by the equation x equals negative b divided by 2a. And this a and b is from the standard form y equals ax squared plus bx plus c. A is the coefficient of the x term, x squared term, b is the coefficient of the x term, and c is the constant. So in our case, a is a negative 10, b is a negative 40. So we got negative 40. B is that negative 40 right there. Over 2 times a, in our case, a being negative 10. Negative is a positive. This leaves us 40 divided by 2 times negative 10 is a negative 20. That is a negative 2. A is negative 2. Actually, technically, it's x equal negative 2. X equal negative 2 is the axis of symmetry. One more time. The axis of symmetry is a line. In this case, it's x equal negative 2. All right, B part. The vertex, well, it goes through the axis of symmetry, so it has that same x value. The vertex will be negative 2. Since the axis of symmetry passes through the vertex, since the axis of symmetry passes through our vertex, they have the same x value. So we knew this negative 2 was going to be in there. Now we just need to take that negative 2 and substitute it in for x. So our y value, y will equal negative 10 times negative 2 squared, substituting negative 2 in for x, minus 9. go ahead. You want to check me using the calculator here. I'm doing this in my head. Negative 2 squared is 4. That's negative 40. Negative 2 times negative 40 will be a plus 80. Then minus 9. That's 40 minus 9 will be a 31. This is the y value of the vertex. That's going to go right there. 2, 31. Your vertex is the ordered pair 231. Do check that with a calculator. On all of these next ones, my guess is that your teacher is standard fare for this kind of problem is a graphing calculator. So hopefully she lets her use a graphing calculator. 74 says f of x is equal to negative 2x squared minus 16x plus 9. This notation f of x, this is just another way to say y. You can think of this as y is equal to negative 2x squared minus 16x plus 9. This is called function notation, and this is equation notation. Just two different ways to come up with the same thing. Well, I'm going to show you the graphing calculator way to look at this. She probably has a graphing calculator, or they have one in school. I'm going to show just one that you can look at online, desmos.com. This is a great free website, and it's got lots of great stuff on it, but they have a nice graphing calculator. So I'm just coming in here, and you can type in f of x or y and equals exactly whatever our equation is, in this case negative 2x squared minus 16x plus 9. And there's the graph. I can zoom out a little bit so you can see it. So she wants to sketch that graph, and then the domain and range. Well, the domain is all real numbers. Any value we can put in for x. The range, this maximum value here is negative 4, 41. This is our vertex. And it's also the highest y value. The range will be all y values less than that. You can see this graph is opening down. Again, it's because this coefficient of x squared is a negative there. So we're just going to sketch this graph. Couple key features. We know where that vertex is. It's that point was negative 441, and a couple other key features are these. These are called the zeros, the x-intercepts. Negative 8.5 about, and a half about. So negative 441, negative 441, and we got one x-intercept there, one x-intercept over there. So missed that one. There you go. Okay. The domain, that is the set of possible x values, is all real numbers. We can put anything we want in there. But the range, the output, is y values less than or equal to 41. We don't get any, we cannot go any higher than 41 in the y department.